Hey there everybody, welcome back to the channel. If you're new here, we're doing a renovation on our 1961 Aljo, which serves as the photo booth camper for our business, Lamp House Photo. In the last video, we got the walls up, we got the ceiling wrap on, and cabinets in, and everything kind of looking like a camper again. So this week, what we need to work on is getting the electrical systems in there so that we can move on later to covering this up with the sheet metal, which eagle-eyed viewers may notice sitting right there underneath the camper. So first of all, when it comes to trailer electrical, I will say that, again, Larry at MobilCraft has a wonderful 3-part video that goes into all of this in much more detail than I'm going to go into. But let me start off by saying that you're going to be working with essentially 3 systems. So you have your basic trailer wiring that works like your brake lights and your tail lights and all that stuff. So I'll call these your running lights. Then you will also have 12-volt sort of interior system, and a lot of things in your camper do run on 12 volt. And then you will have a 120-volt system for when you're plugged into shore power. So your running lights, we're talking about like your stop lights and your turn signals and stuff like that. Stop lights, let's write that up there. Turn signals. This happens to also be a 12-volt system because most cars are 12-volt, and this is the part that plugs into your car. The 12-volt system on the inside, this is to run things that might run off of battery power if you have an onboard battery. So this might include your interior lights, propane refrigerator, or if you have a 12-volt refrigerator. Of course, your 120 volt, this is going to be anything that you would normally plug in your house. So like a microwave, hair dryer. But so these are going to be big electrical items, essentially. Now these systems may interact with one another. You may have an auxiliary power coming from your automobile, so when you're driving it, it's running off your car's alternator. Those may interact, and your 120 volt system will also interact with your 12 volt because you will probably have a power converter that runs your 12 volt system. Now you may have, in your 12 volt system, you may have an inverter that's combined with a battery, and that will allow you to run your 120 volt system when you're not plugged in. Like I said, these things can interact. They're not 3 wholly separate systems, although in my case, I am not doing an inverter, but I am doing a power converter. So these will interact this way. This here is not really going to be tied into anything else. So let's talk amperage, because that's the other thing that people kind of get hung up on. So most of the time you're going to find campers that are set up for 15 amp, 30 amp, or 50 amp. 50 amp systems are going to be for your really, really big campers. So we're not going to be talking about 50 amp systems. So the question is 15 amp or 30 amp. 15 amp and 30 amp, these are both 120 volt systems. So there's no difference there. The only difference is how much power you have to run things. So a 15 amp system is going to be like a single household electrical outlet. A 30 amp system would be like 2 circuits. So 2 different breakers in your house for normal outlets. Our photo booth camper could run on 15 amps, and 99% of the time it's going to run on 15 amps because you show up somewhere to plug in and they're going to have a single 15 amp outlet for you. I am installing a 30 amp system though because it allows me to have 2 breakers and kind of split things out, and I can use just a regular RV type 30 amp cord with a 15 amp adapter on it to plug in, and then I've got a nice heavy duty cord that people aren't going to trip over. So whatever you have, that power is going to go into your breaker box. In that breaker box, you will have breakers that will kind of divide that up. Now with a 15 amp system, really you should just have one 15 amp breaker in there. With 30 amp, you can do 2 15 amp breakers in there, and then spread those out from there. So in my system, doing 30 amp, I'm going to have the 2 breakers, and one of those is going to go to an outlet that a power converter will plug into, and then that will go and run my 12 volt system. The other will go to a whole series of outlets, and this is all going to stay as 120 volt straight from the wall in through the breaker and out to these outlets, and this is what all the photo booth stuff is going to plug into. I'm going to add GFCI protection, which you could do 2 GFCI protected breakers, but they didn't have those at my store and I didn't want to order them and wait on that, so I'm going to install this as a GFCI outlet there, and then I'm going to do another one right here. Now GFCI will protect all the other ones down the stream. It doesn't care what's on this side, but it will protect all the rest of these, and that stands for ground fault circuit interrupter. You want to use those anywhere where moisture could be an issue. If it is an outdoor outlet, like I'm actually going to put an outlet on the outside of my camper, so this one will need to have its own GFCI outlet. So that will be a little bit redundant, but in general, you want to follow the guidelines of the National Electric Code, and that will generally keep you safe. And National Electric Code, NEC, says that any outdoor outlet must be GFCI. So this one's going to be GFCI, even though it's already protected on this run. You know, it says additional things like if you're going to put an outlet on a countertop next to a sink or, you know, things like that, you know, it needs to be GFCI. I don't have a sink in there, but I'm still including GFCI because you never know. You can get water in a camper. It's good to have this extra protection. Now, granted, all of these are grounded outlets as well. The skin's grounded. Basically, every metal part of the camper's grounded. These are really just a redundant measure. Also, if you're plugging in outside to a wall or something, that should also be a GFCI outlet. So again, you should have it even on this side of things. But you know, you never know, so you want to kind of build in redundancies and make sure that things are safe and groovy. Yeah, okay, let's move on. So I'll be using a square D box for this camper, but so it will be getting 2 breakers in it. The one thing you absolutely must do with one of these is to wire this up as though it were a secondary panel. I've talked to a number of people that have had electrical problems, and when you get into it, what they've done is they have put their ground wires and their neutral wires on the same bus bar. Bus bars are these little things right here that have a bunch of screws in them, and you must have a separate ground bus bar in a secondary panel. In your main panel, like you might have in your house that controls all the power, your ground wires and your neutrals will likely come and attach to the same bus bar. So then when you wire this up, you'll have your 30 amp coming in, and it'll come down and attach to one of these 2. These are not connected, so you need a jumper wire that goes from one to the other, and then your breakers click in there, and your other wire, your other black wire, your hot wire, comes out there and goes out of each breaker and goes to their own separate branches or circuits. I'm not an electrician, so neutral wire, your white wire, will come and it'll attach here, and then from these 2 it'll go out into those other circuits. In general, you only want to use 1 wire per screw on a bus bar. It's not a good idea to double them up. Okay, so when it comes to the running lights on your trailer, your brake lights, your turn signal, stuff like that, what you'll generally want to do is just go and get a little trailer wiring kit that comes with these 4 color-coded wires. This is your most sort of basic kind of 4-way trailer wiring. Your white is your ground wire, your brown is your running lights, and then your yellow and green are your turn signal lights. Now you would say, whoa, don't you need one for brake lights as well? Well, what it does for brake lights is it just blinks both the left and turn signal at the same time. You'll have a brown wire that goes to every single light, because that's, like I said, your running lights. That's when you turn your headlights on and your lights light up. And then your left and right turn signal will each get either a green or a yellow in addition to the brown. What I usually like to do is to also run a ground wire to each one of those lights. They're designed so that they ground through the trailer skin, but if you have brand new skin and a good contact between the fixture and the skin, then you're fine. But over time, things loosen up. Usually if you have a light that's not working, it's probably because your ground is bad. So I just run a separate ground to them, and then I've never had a problem with one that I've ground individually. If you get the kits, it'll come with a connector. If you don't get the kit, you will need a connector. This is a 7-way connector. You might realize that I said it's a 4-way trailer wiring setup. Well, yes, it is. So you don't really need a 7-way connector, you need a 4-way connector. But think about what kind of vehicles you have. Every one of my cars has a 7-way connector on it, so I use a 7-way connector on my trailer. You can use a 4-way connector, but then what you'll have to do is you'll have to get a 4-way to 7-way adapter. I would rather just have one thing that I can plug straight into my car. This here comes with this little box. This is where all your connectors are made. This is the one I took off of there, and it's the one that's going back on there. But it mounts up under the chassis somewhere, and then your wires come out of this and go off to your running lights. I bought this off Amazon, but I understand this is a common problem with these. The color coding on these wires is incorrect. When you open this up, you might be able to see in here, there's these color-coded wires that come in here, and they are all your standard 7-way colors, but they do not match up according to the colors that we use on our 4-way wiring system. What I had to do is take my multimeter and check each pin with each terminal here to figure out what the correct terminal was to actually use for the right thing. So just be aware of that. If you buy one of these on Amazon, don't go off of the color coding on these wires. Take a multimeter and figure it out for yourself, or you will be confused as to why your lights don't work the way they're supposed to. Okay, so I've sort of located where my little junction box for my trailer wiring needs to go. You want a little bit of slack in this just in case, but you don't want it to be so slack that it's going to drag on the ground when it's connected to your vehicle. This is about where I need it to be, so I'm going to disconnect these old wires, and I'm going to crimp on some new ring connectors to the ends of my new wires and attach those where they need to be. So with this trailer wiring, you can just pull it apart. Matching up my old ones with my new ones. Brown goes to, oh, nope. Brown goes to green. Yellow goes to red. And I need to add one additional ground that will go to the chassis. So with my cord run now, I'm going to drill across this way at the same height so I can run this back to my marker lights. So on the back here, I held my old skin up to this and I just kind of marked where the lights were so I could run the wires to them. Like I said, there's going to be a separate ground for each of these. So the ground wire needs to run all the way, and then I'm going to tap into it at various spots once I get the lights up here. What I'm going to do right here is I'm going to drill through this, and then I'm going to use my router to cut a channel into this. And then this little circle is going to get cut out. And then I'm going to run a channel down here and run the wire across the bottom of this. It'll go to the license plate light, and it'll also go to the other tail light, and then around the side to the other marker light. So with my holes and stuff drilled, I'm just making sure that the ends of all my cords line up to where the lights are going to be. And then I'll just wrap them up and tie them off for right now, so I can come back and attach everything later once the skins are on. So this is the ground wire to the chassis for the trailer lights. So I'm just going to put a little heat shrink on that just to make it nice since it's a little bit exposed. Just get my wrenches and tighten that up. So one of the first things I'm going to want to do is to find out where I'm going to install the breaker box. And I kind of think maybe somewhere right about there is a good spot for it, because my outlet is going to come in above it. Because this is so long, it's going to protrude into the interior just a little bit. But I want it to be right about there, I think. So then let's just drill a hole and see what's on the other side. So it's right here. It's ways above my trailer wiring, so I'm not worried about that. So that will wind up right there on the outside, and that's where the 30 amp will plug into it. So what I've marked are where the screws go that actually attach this to the wall, and those spots will need bracing behind it. I've also marked these two spots where there's knockouts on the bottom, these open areas on the back, and those will have wire for the two branches of this circuit coming out of them and going back into the wall. Just going to put a couple screws in to hang this off of temporarily. So these are your basic kind of clamp connectors. Anytime you have wire that goes into or out of a box, you want to have one of these that it runs through, and this prevents it from getting yanked out of the box. And they just go on the outside. Funny shaped washer with little nubs on it that goes on the inside. So think about the way that's oriented. If you're having this go back in the wall, if you're going to make a hole for that to fit into, you obviously don't want it pointing that way and not allowing you to tighten these down. So just make sure it's pointed out of the way, whatever way that is. So then once there's bracing on the back side of that, it won't be quite so flimsy here, so don't worry about that. So a little bracing behind there as well, and we will be good. So there's actually the opportunity down here to put an outlet on the back side of this and be able to use a regular blue plastic work box. That'll sit right in there, and then the wires from this will go into the wall, and then they'll come back out here and into that. This will have a GFCI outlet in it, and it'll be the first one on the other breaker, so that will protect the rest of the circuit. So I'm just going to cut through from this side. I've already drawn it out on there, and then we'll just put this one in place. There we go. That's all the boxes. So we need to drill a big hole right here where the back of the power inlet's going to come in, and then we need to attach the 10 gauge wiring that would carry the theoretical 30 amps into the breaker box. I should say, since this camper doesn't really go to campsites, the likelihood of ever plugging into a 30 amp outlet is pretty low, but if you have a 30 amp inlet, you need to have it wired to potentially carry all that. Be careful with these big hole saws, folks, because if there's one thing that I've injured myself with more in the shop, it's these things. So this is the back of the outlet right here. And the wires are actually going to come down through this little clamp and they'll go right into the top of our box. So like I said, I'll probably eventually make a little shroud to just cover this area just to keep it safe and secure. But for right now, we're just going to run it down into there. So we'll need to knock this out, put a little cable clamp in there, and we can wire this up. Okay, so when it comes to wiring one of these up, you're going to have your 3 wires. Black is your positive, white is your neutral, and green is your ground. So they're going to come in from your inlet. They're going to go down in there. Your black's going to go up here. Your white's going to go here. And your green's going to go over here to your grounding bus bar that you've added. Then your 2 breakers will go here. And they will have black wires from your circuits. White wires from your circuits will connect over here to your neutral bar. And then your grounding wires from your circuits will connect over here to your ground bus bar. The one other thing that's going to connect on your ground bus bar is a grounding wire that's going to go down to the chassis frame and ground it. One thing I forgot to mention, obviously you're plugging this into one of these. You actually need to have a little jumper that goes and connects this other one. To do that, you just need a little length of cable. So, get it all together, you test your connections, make sure it's all good, and then your faceplate goes on and you're good to go. Hang it up. I'm going to take this piece. Then we're going to take that loose and run it through there. So the real question is how much you want to leave in the wall. I think I want to leave about this much. So I'll probably put a staple there just to keep this nice and secure. It's not a bad idea to secure lines a little better than you would in your house, just because this thing's going to be going down the road. Now this is going to have a GFCI outlet in it because I want GFCI protection on all of these. These outlets will have a little yellow sticker on the back and it covers a couple of the terminals. That's where it goes on to the next outlet. This is only going to have one outlet because this is where the 12-volt converter box plugs in. So I'm just going to leave that in place and we're just going to use these 2. There's a brass screw and a silver screw. Silver is for your white because it's, I don't know, kind of white. Black goes to your brass. And then your ground obviously goes to your ground screw. Since this is a metal box, we also need another ground that will go to this ground terminal in the back of it. And we'll use one of those little green screws for that. By the way, almost all outlets have a little spot on the back that tells you how much to strip off of the ends of your wires. And then your little wire strippers have a perfect little spot to fold a shepherd's hook into that. Hooks always go to the right. There shouldn't be any insulation underneath the screw. So I like to use these little push terminals. Some people don't like them, they don't trust them, whatever. They are made for this job. And this is a pretty low circuit, so I'm not too worried about. So you can see through there that the wires are going all the way in, so you know you have connection. Okay, so with that wired up, I need to go back through with this cable, and I think it needs to go through right about here. I could be wrong. Let's find out. Okay. So you're not going to be able to see me do this because this is too tight a space for me to get the camera in here. But this is the first outlet in our second circuit. It's going to have a GFCI outlet on it, and that will protect all the other outlets down the line. This here's a plastic box, so it doesn't have to be grounded, but we will still have a pigtail to connect both of these to this green screw right here. And on this one, we will be taking off this yellow tape for the load line. So this one coming in is the line, this one coming out is the load. Other than that, it's pretty simple. Okay, so to convert your 120 volt into 12 volt, you need a power converter box. And this has a little regular 120 volt plug on the back. So it plugs into this outlet that I installed here, which is on this breaker here. And then this is wired into a fuse panel, which we'll set up here, and looks like this. And then from that fuse panel, you will have all of your 12 volt accessories and whatnot wired into that. You need to ground this to your frame, and then you've got a positive and a negative that will connect to this. And there you go. Now, in most RVs, you'll have a battery, and so your battery is also connected into this 12 volt system, and this is actually what charges that battery. The battery you can think of as actually running all the 12 volt stuff, so as power goes out of that, this puts power back into it. But you can use this without a battery just to directly power everything off of shore power. For when it's connected to a battery, it has a 3-stage charging mode that will keep the battery charged up and healthy. But actually, for what I'm doing, since I don't have a battery on here, at least right now, I'm just going to switch it into fixed output. And what you need to know is that a 12 volt system is not really 12 volts. So I'm going to switch it to fixed output, and then I'm going to set this probably about 13.6 volts, and that should be good for all my accessories. Okay. So with my fuse panel in here, I'm going to go ahead and start running my 12 volt wire to my fan and to my one light that's on the other side of the camper. So I'll use 12 gauge stranded wire, although you could use thinner stuff. The actual fan, I think it says minimum 16 gauge, so yeah, you can go a lot thinner. But I've got 12 on hand, so that's what I'm using. So I'm going to put some ring terminals on here so that we can attach them to the fuse panel. Okay, so with this little fuse panel from our converter box, we will have two nice big thick wires that go to these two terminals, your negative and your positive, and then everything else that wires into it, the negative is going to come up here, and the positive is going to go in here at the side. Like I said, I only have two things, so I'll probably run one here and here, and the other one will be over here. So for the most part, the cable for that light on the other side is going to follow the cable for the fan. It just takes a slight diversion and goes all the way across the top. So just going to drill some holes for it. So one thing you should probably go ahead and do as soon as you start getting your circuits in there, different fuse boxes come with different things. This one comes with a bunch of little stickers, some of which are kind of similar to the things that I'm doing. I suggest you go ahead and start marking your circuits so you don't get confused and forget which one goes where. Anyway, I'm going to put some stickers on, and then I'm going to put my ring connectors on this, attach it there, and then secure all these wires, and then I'll connect the last two to the power box, converter box, whatever it's called. we'll straighten all those up. Okay, so with the fuse panel pretty well wired in there, you need to put fuses in for anything to work. This is my light on the other side. It pulls about 1.5 amps, so if it were to pull, say, 5 amps, something would be wrong. So we'll put a little 5 amp fuse in there, and then I'm going to go get my instructions for my fantastic fan and see what kind of fuse we should put in there. Okay, so I think that's pretty much going to wrap up the electrical on this. This is actually a very simple camper to wire up. That being said, if you're not comfortable working on electrical, and you know, it should never be understated that you can really hurt yourself or others by doing something wrong, you know, you can always hire someone to do it. If you know somebody that is comfortable with electrical, they can probably advise you on this. If you are an electrical professional and see something that I have done incredibly foolishly, please let me know in the comments so that I can fix it and avoid hurting myself or others. Thanks for watching. Please like and subscribe. I think the next video is going to be interesting because it's something that I haven't done before, so please make sure and stay tuned, and we'll see you in the next one. Pretty pitiful, shorty. Pretty pitiful.